Hello and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is using ITX to generate a V4 UUID. Feel free to reach out to me on popular social media channels at Paul Brett IBM. In this practical demonstration, I use the ITX function from the resourcelib library GETITXUID and then modify its result to get a string that is visually compatible with the V4 specification, i.e. a group of 8 numbers, a hyphen, a group of 4 numbers, a hyphen, a group of 4 numbers starting with a 4, then a hyphen, a group of 4 numbers starting with a random character from a set of 4, either A, B, 8 or 9, then a hyphen and a series of 12 characters. This was the brief for a customer project, and I thought it was a good teaching exercise on how to slowly build up a map to do what you want. We start this demonstration in the ITX Design Studio. I'm using 10.1.2.0 here. You will note that I have one project called UUID and within that one map source file called test.mms. In test.mms I have various stages where I go through the different functions that I added to the map to try to get what I need at the end, and a final solution file which we will go through and I will add to the video as a link. So let's start with map test 1 and the raw function resourcelib-GETITXUID. I build and run this map. This map creates a file called output1.txt, and if we have a look at the content, we have a series of 36 characters. Each character is either an alphanumeric in the range of 0 to 9 or A to F. Moving on to test 2, you will note that I am grabbing in output card 2 using the mid function from character 1 for 8 characters and then appending a hyphen, then from character 9 for 4 characters, then a hyphen, then from 13 for 4, then a hyphen, then from 17 to 4 with a hyphen, and finally from 21 for 12 characters. If I run this map, I now have both output 1 and output 2, and if I open output 2 you can see what those mid functions have done. It has taken the UUID and basically just separated it out into the groups that I need for my final result, 8, 4, 4, 4, 12. Moving on a step then, because group number 3 needs to start with a set character. Group number 3, I'm now, instead of taking the 13th character for 4 characters, I'm now taking the 14th character for 3 and prepending it manually just after the hyphen with a 4. This is still writing to the file output2.txt. So if we look at the result now, we will note that this character is always going to be a 4. However, for the next group of characters, we need to have some kind of randomness introduced. For this position here, instead of a 0, we need it to contain one of 4 characters, either an A, a B, an 8 or a 9. So the next iteration of our map, test 4, I'm going to introduce an input card with a fixed string of the 4 characters that we can potentially choose from. In output card number 2, I'm now using a mod rand function to choose a random number between 1 and 4. And then in my string concatenation section, between the hyphens that we had before, I am taking the middle of the in1 string, all the others are taking parts of out1. This is taking the middle of in1 string and then using the random number that was chosen in output card 2, either 1, 2, 3 or 4, for one character. So it's picking one of those characters at random and inserting it in place of the first part of this section. There's no hyphen between these two, there's the hyphen, there's the hyphen. So this is one character, and here we are taking 3 characters from position 18. This card is now writing to output3.txt. If I run this map, I can now open output 3, and you will note that this character this time has chosen to be an 8. If I close this, run it one more time, and open the output file again, we still get an 8. Okay, let's try again. And this time we have a B. So this is truly being random and choosing either A, B, 8 or 9. This is a fixed 4, everything else remains as it was. Now the final stage for my map is to convert the entire thing into lowercase. So if we go to the final map in the string Z solution, we use the lowercase function to take the previously created string and write it out to output4.txt. If I run this map, switch to output 4, here we have our final UUID string that is compatible with the v4 specification. In theory, you should be able to run hundreds of thousands of iterations of this map every minute of every day for many, many years before you get any kind of duplication. You can be confident that this is going to be unique within your project. And that's how I've used ITX to build a v4 compatible UUID string. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, hit that like button, perhaps leave a comment. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett IBM. Thank you.